With zero crew on board and a remote operator watching from a control room on shore, the world's first fully autonomous commercial cargo ship completed its maiden voyage. In 2022, 62 nautical miles across a Norwegian fjord, carrying 1,500 tons of fertilizer. The Yara Birkeland didn't make news because it was experimental. It made news because it worked. And because the economics behind it are rewriting the cost structure of an industry that moves 90% of everything the world trades. Crewed vessels spend 40 to 50% of their operating budget on the people required to sail them. Remove the crew and that cost disappears, along with the cabins, the galleys, the medical facilities, and the liability that comes with putting humans at sea for months at a time. Here's why the math is pushing the shipping industry toward a future with nobody at the helm. To understand this, start with one basic structural fact. Keeping humans alive at sea is extraordinarily expensive, and that cost has been rising consistently for decades, while the freight rates those humans help generate have compressed in the opposite direction. A standard large commercial vessel, a container ship, a bulk carrier, a product tanker, requires between 20 and 25 crew members at minimum safe manning levels set by the International Maritime Organization's Standards of Training Certification and Watchkeeping Convention. That convention, known as STCW, establishes the minimum qualifications, certifications, and watchkeeping requirements for every officer and rating on board. It was last comprehensively revised in 2010. It was written entirely around the assumption that every commercial vessel underway would have qualified humans on the bridge at all times. Under that framework, a shipping company doesn't choose how many people to put on a vessel, the way it chooses how many containers to load. The crew complement is a regulatory flaw, not a business decision. And that regulatory flaw has a cost that flows directly from the number of people the IMO requires to be on board, through the wages those people earn, the training they must complete, the medical standards they must meet, the flights home they must be provided at the end of each contract, and the physical infrastructure the vessel must carry to keep them alive, fed, and safe across ocean passages that can last weeks or months. The average manning cost for a large commercial vessel, combining wages, training, certification, rotation, and the infrastructure costs of maintaining crew accommodation at sea, runs between $3.5 and $5 million annually. On a vessel earning freight revenue that fluctuates with global trade volumes and spot market rates, that $4 to $7 million annual baseline is a fixed cost that the vessel must cover before its owner sees a dollar of profit. When freight rates are high, as they were during the supply chain disruption years of 2021 and 2022, that fixed cost is absorbable. When freight rates correct, as they did sharply through 2023 and 2024, the manning cost doesn't move with them. The vessel still needs 25 people. The certification still costs the same. The flights home still cost the same. So the shipping company is stuck with two choices: maintain full crew complement and absorb the manning cost regardless of what the freight market does, or transition toward autonomous and reduced crew operations and eliminate the largest single controllable cost on the vessel's operating budget. The economics of the second option are what the Yara Birkeland proved. So what does it actually cost to crew a large commercial vessel for a single year? It starts with wages. A senior officer on a large commercial vessel earns between $8,000 and $15,000 per month, depending on rank, vessel type, and flag state. A full crew of 20 to 25 people across all ranks costs between $200,000 and $400,000 per month in combined wages, benefits, and mandatory overtime. Annualized, that is $2.4 to $4.8 million per vessel in wages alone. Then there is training and certification. The IMO's STCW convention requires ongoing training, medical examination, and certification renewal for every officer and rating on board. A shipping company rotating crews every 4 to 6 months spends between $500,000 and $1.5 million annually per vessel in training courses, certification examinations, and flag state endorsement fees. These costs don't generate revenue, they generate compliance. Then there is crew rotation and repatriation. At the end of every contract, the entire crew must be flown home and a replacement crew flown in. For a vessel drawing crew from the Philippines, which supplies approximately 30% of the world's commercial seafarers, a full rotation involves international flights for 20 to 25 people routing through Manila. Annual repatriation costs per vessel run between $115,000 and $300,000. But the cost that rarely appears in the public conversation about autonomous shipping is the infrastructure displacement cost. Every crewed ship carries sleeping quarters, galleys, fresh water systems, medical facilities, and life-saving equipment for every person on board. Space occupied by crew quarters is space that cannot carry cargo. That displaced capacity is freight revenue that never gets earned on every single voyage the vessel makes. When you add wages, training, rotation, and infrastructure displacement together, the full annual manning cost for a single large commercial vessel runs between $4 and $7 million, spent before the vessel earns a single dollar of freight revenue. So if crewing a vessel costs $4 to $7 million a year, what does removing the crew actually save? The Yara Birkeland's autonomous system cost approximately $25 million to develop and install, a figure skeptics pointed to as evidence this was a technology experiment rather than an economic proposition. The math those skeptics missed is the timeline. At $4 million per year in manning savings, the system pays for itself in 6.25 years. At $5 million in 5 years, the Yara Birkeland has an expected operational life of 30 years. By year 7, every dollar saved is pure cost reduction. Over 30 years, the total saving exceeds $120 million against a $25 million system cost. A crewed vessel over 20 years, $80 to $140 million in manning costs, rising with wage inflation and certification increases. An autonomous vessel over the same period, a $25 million upfront cost and near zero ongoing manning expense. The math doesn't make a suggestion, it gives an order. Here's what nobody talks about. The economics of autonomous shipping have been proven since 2022. The reason the world's oceans are not already filling with crewless vessels is not technological. It is structural, and the structure slowing adoption is one of the most significant labor ecosystems in the global economy. The Philippines supplies approximately 30% of the world's commercial seafarers. The remittances those sailors send home total approximately $6 billion per year, making maritime labor one of the Philippines' most significant economic exports. The International Transport Workers Federation has been explicit about the threat autonomous shipping represents to that labor base. So has the Philippine Overseas Employment Administration, which manages the overseas placement of Filipino workers and collects significant fees from the crewing agencies that place them on vessels. The International Maritime Organization has been studying autonomous vessel regulations since 2017 under its Maritime Autonomous Surface Ships Work Plan. 8 years of working group meetings have produced interim guidelines, but no binding international framework permitting fully autonomous vessels in international waters. The shipping companies that want to deploy autonomous vessels on trans-Pacific or transatlantic routes cannot do so legally under current international maritime law. There have been attempts to move faster. Norway established the world's first autonomous shipping corridor in the Oslofjord in 2018, enabling the Yara Birkeland's domestic trials under Norwegian law rather than international convention. Within Norwegian territorial waters, the vessel can sail without a crew. The moment it crosses into international waters, solace applies, and solace requires a licensed officer on the bridge. That regulatory gap is the product of a deliberate institutional process at the IMO, in which flag states, seafarer unions, training institutions, and maritime labor exporters all participate. Each has a financial interest in the continuation of the crewed vessel model. The mass work plan cannot move faster than its most resistant members, and the current timeline for a binding international framework points toward the early 2030s. In the meantime, Kongsberg Maritime continues refining its remote operation platform. Rolls-Royce's Marine Division, now part of Kongsberg, has been developing autonomous vessel technology since 2012. Chinese shipbuilders have launched multiple autonomous trials on domestic coastal routes. The economics are not in dispute anywhere in the industry. The international regulatory framework has not caught up with them. So the strange truth remains: it is cheaper to sail a commercial vessel across the ocean with no crew than to staff it with the 25 people international maritime law currently requires. The shipping company isn't cutting corners. It's being rational inside a system where the cost of keeping humans at sea has outgrown the revenue those humans generate. That's not a maritime problem. That pattern shows up in every industry you've never thought to look at.